Hello. Today we will be talking about a method to reduce carbon dioxide emissions from the production of concrete in an Ontario-based production plant.
What is concrete? Concrete is a material that is composed of crushed rock, sand, water, and cement. Concrete is the second most used material by humans on the planet behind water. Cement is the main component of concrete, and cement is composed of mostly limestone. Baking rocks to make concrete is responsible for nearly 8% of worldwide carbon dioxide emissions.
What's wrong with concrete? Concrete is everywhere roads, buildings, bridges, and the key ingredient is cement. The problem is how cement is made. It starts as limestone, basically rock, and we heat it in a giant kiln, like an industrial oven. When you bake that rock, it doesn't just take energy, it actually releases carbon dioxide as part of the chemistry. So cement has two CO2 sources burning fuel for heat and the rock itself breaking down. Because we make so much cement worldwide, those emissions add up fast. So, how do we fix it? Our fix starts from the end goal. If we want to store CO2 underground, we need a CO2 stream that's concentrated and clean enough to compress and transport. That's why we change how the kiln runs. Instead of burning fuel in normal air, we use high purity oxygen, which avoids mixing the exhaust with a bunch of nitrogen from air. The result is a flue gas that's much richer in CO2, making capture way easier. So our design combines the three pieces: oxygen production, kiln modifications to run on oxygen safely, and a CO2 capture and conditioning system for storage.
We will need a large supply of oxygen. Thankfully, the air around us is primarily composed of nitrogen and oxygen, and these two gases have different boiling points. So when we cool them down to a very low temperature, near a negative 190 degrees Celsius, the oxygen in the air will condense into a liquid, but the nitrogen will remain a gas. This will cause a bubbling effect, kind of like when you open a can of Pepsi, where the nitrogen bubbles that are gaseous will bubble through the liquid oxygen and separate themselves into pure oxygen and pure nitrogen. This is how we will mass produce the oxygen that is needed in this process.
The main idea behind this new kiln is simple. We want to burn coal more completely. By adding more oxygen inside the kiln, the coal burns cleaner and more efficiently. That means we produce far less soot, tar, and other unwanted byproducts, and more of what we actually want: heat. Because we're getting more heat out of every kilogram of coal, we can use less coal to make the same amount of concrete. That lowers fuel use and reduces emissions at the same time. The graphic at the bottom shows this idea visually. We want more carbon ending up as carbon dioxide and water, and less carbon turning into soot.
Carbon capture. The carbon capture portion of this project will be done with underground injection. After the gas comes out of the oven, it will be treated to remove the water and other impurities, like oxygen. Then all the CO2 heads to a well. This well takes the CO2 and injects it underground into deep caverns. The caverns will be sealed, and slowly the CO2 will react with the surrounding rock to create more limestone.
We're able to eliminate almost all of the CO2 emissions, recycling it back underground without changing the quality of the concrete. And the big upside is that the nitrogen we produce that can be sold will pay for this entire process. So our industry sponsors and companies around the world will be able to implement this process at all scales of concrete production.